Welcome online. I'm Sabesh, and I'm the co-organizer of MLX India, the community. Um, and as part of MLX India, we've hosted a bunch of events before this. All of them were offline. So we we started, all of this started with a discussion with me and Kautuk, who I work with, and we were talking about local models and running them. And we were tinkering a lot around MLX and really geeking about how things worked with like local AI in that space. So we were like, okay, we need a community to share our notes and exchange discussions, and that's how MLX India, the community, was formed. And we've received overwhelming response actually, and it's been like pretty thrilling to see the community grow from like no like literally nobody to 800 plus members today. So I'm really glad that we're here, and this only goes to resonate the interest in local models and owning your intelligence. So we hosted a bunch of events previously. We hosted a community meetup in Bangalore, and then that took off well. So we thought, okay, we'll meet people in their own cities. So we traveled to 5 different cities. We had our community meetup too in 5 cities at the same time, and then that was a hit as well. So now we just wanted to make it a bit more versatile. We're just experimenting with a lot of different formats here, I understand. But we thought, okay, let's do a series of online meetups where we get to share some discussions and thoughts that we've been accumulating for a while, and hear from you guys as well, and take this meetup on. And that's what prompted this. So yes, without much further ado, I'd like to continue ahead with MLX India Community Meetup 3, the online edition. So let's go over the quick agenda for today. Um, Starting off, I will be going ahead. There's going to be two speakers. There's going to be me and Sagar. Um, so I will start off with the topic of WWDC and CoreAI and Apple's whole thoughts on it. And then we will be moving on to building CoreAI compatible models using Python. And then we will then go on to the whole inference side of things that Sagar will be talking more about on iOS. And then there's like a TestFlight drop of the app that we have been working on, followed by the question and answer session where we get to see things that are being discussed. And as I'm presenting, feel free to drop in questions, or I would actually suggest you like take it and put it in the end as well, whatever works for you guys. But yeah, so yes, let's get started. Um, so WWDC 26 was, I think, around this time last month, and it came with a bang. It came with a lot of cool tech that we were really excited about. And one pivotal element of this was Core AI, and it was their framework that lets you run local, model inference right on iOS. So, I'd like to talk a bit about that before we get a bit more hands-on into this. So what is Core AI? It's Apple's take for local AI on Apple platforms. So what it helps you do is run local AI models offline on Apple Silicon. That is your iOS, macOS for now. And it also leverages the Apple Neural Engine, which is the ANE. So it's efficient that way. And it's also not tied to the new AFM series of models that they dropped, Apple Foundation models. It lets you leverage your own models as well. So you can bring your own model. That's the basic gist of what this is. And so WWDC featured a lot about Siri and Siri AI and foundation models and Core AI as well. So we were just like, trying to understand the positioning that Apple has been doing here. So Core AI is basically their in-house inference platform right now. And I and the team have observed some things that we'd like to emphasize here. So before WWDC, it was also possible to run inference on local models using MLX Swift. And this was something that we have tinkered around with, and we have we've made contributions to MLX Swift as well, and it's an open source repo. And the landscape with MLX Swift was a little shaky, and things were moving pretty in like different directions, I would say. And with this dub, the focus from MLX Swift was shifted away from running AI inference to other things like running heavy MATMLOps in general. So if you look at their MLX sessions for this year from WWDC, you will see how they talk about running computationally heavy mathematics using MLX Swift on device. And there's not going to be mentions of running AI inference or language models in general. And that's because CoreAI has come in right now as a new player, and its entire job is to like bring your own model and we'll run inference right with Core AI under in iOS and macOS. And if you notice, there's also this one more change that happened, which is Apple focuses on foundation models, Apple foundation models for a lot of things. So it's their own intelligence language model layer. And Core AI's features were also shifted a little away to other features like audio diarization, image analysis, etc. So this just goes to say how Apple's been positioning these products, wherein they really want to keep their foundation models at the top, wherein people will be using that reliably for on-device engineering, on-device inference. And you can utilize Core AI when you want your own intelligence, but they're not really focusing on the language model aspect of it. They're focusing on just like bringing your general models to Apple platforms. So this retains the focus on their proprietary AFM, and Core AI also is their own in-house proprietary framework. Some confusions and questions that we've been having are regarding the whole MLX versus Core ML versus Core AI dilemma. All of these are very useful technologies and tool chains, and this is where they differ. So Apple has long had the Core ML, which is for creating legacy machine learning inference. So it had features for you to do simple things like regressions, classifications, and object detection and image classification, etc. So these are simple machine learning techniques. I think some include like decision trees, random forest, things like that. And Core AI has come in with the whole prospect of letting you run inference using a neural network, which is really cool. Which now enables you to, it just unlocks a whole realm of things that you can do with Core AI on device. Meaning you can run complicated architectures like transformers, which let you run language models. MLX is still the powerhouse for training and experiments. So how we like to think of it and how it's positioned right now is MLX is the lab where you do experimenting and tweaking around and tinkering. And it lets you do far wide more things than just running inference on a model. It lets you train, it lets you fine tune, and it lets you just like do a lot more things like quantization, etc. That otherwise you couldn't do on a framework like Core AI. It's much more sophisticated like that. But yeah, it comes with its own cons, which we'll get to. So why Core AI? What do you get when you use Core AI? So initially we were thinking, it must be speed because it uses the Apple Neural Engine. Unlike MLX, MLX only uses the CPU and GPU. You cannot run inference on the Neural Engine, but Core AI does that. Core AI is very similar to how Core ML works, and it leverages the neural accelerators that are present in this Apple Silicon, giving you much faster prefill speeds on your language models. So we thought speed was the whole thing, but if you think about it, it's a bit more nuanced than that. It's about efficiency and it's about resource sharing. So these are key terms I would like to highlight here. You don't just bring speed when you move to Core AI because it's like the neural network is the neural engine is meant for operations like this. You also do this thing where you split your resources. So by running a model on neural engine, your GPU becomes free to do other things. Like maybe you're running a game and the game needs a model which runs on the A&E. So this is one thing that we've that's possible. The other one is the neural engine is meant for heavy MATML operations, meaning it will let you do it more efficiently. So the wattage here is like really low. So questions that we can explore and ask are running things on the neural engine is it better for my battery life than running it on the using MLX, etc. So these are the type of questions that we should be asking about this. These are the benchmarks that we need. And what you can do with Core obviously is ship small local models that run right on your phone and Mac. So Core runs on all of Apple Silicon. It's the inference is distributed across the CPU, GPU, and A&E. And the advantages include full privacy. There is no dependencies on the server. There's zero cloud costs, etc. And you can scale this up from like small models up to like very large vision models, and that's the beauty of it. So there's a lot of terms that CoreAI comes packaged with. Excuse me. So when you run inference on a CoreAI model, CoreAI specializes the model for a target device on first load. And as a result, you can also utilize the cache that they have, so that you can just the AI model cache lets you check and preload it before the user requests fresh hit again. So this is one benefit that they have. The specialization is also a very nice concept that lets you lets the model adapt to the device, the target device, based on what the device's constraints are. You don't want like a much computationally heavy model running on like a smaller phone, like let's say iPhone 12, etc. So this is the benefit of using specialization, which comes built in. And one more major advantage is that it has ahead of time compilation instead of just in time. So it does a lot of the heavy lifting for the model ahead of the first run itself. So users get a much better experience when they run it right out of the box. And I'd also like to brush over updates from MLX this WWDC. With CoreAI, we saw like the ultimate inference engine that iOS can have. So it lets you leverage the ANE, it's very efficient, and it lets you bring your own model and lets you run inference on it. And Apple is still pushing the foundation models framework, and they have released high-level Swift APIs for CoreAI language model and MLX language model, which you can utilize to bring your own models, but use the framework of the foundation models. So you'll be pretty much be adhering to the foundation models framework, wherein you can think of it as interop. You can just switch between MLX or like basic foundation models or private cloud compute as and when you need. So this was the advantage of using adhering to the foundation models framework, and you don't have to write your own custom logic of running inference basically. And what MLX got this year also was distributed training over RDMA, remote direct memory access, and it has like Metal 4 support, which makes it faster and like more efficient. This thing was like the whole process of distributed training was featured in Apple this year, like at the Institute of Theatre by LM Studio, where they daisy chained 4 Mac studios and they were able to run inference on it. Pretty cool. So, and finally, about the general push from WWDC, I'd like to cover is the availability of it. It's CoreAI as a package is available with Xcode 27 beta, and like it lets you run inference on all the beta operating systems. Apple Foundation models is tied to Siri AI, and CoreAI is not. So if you want to leverage the newer Apple Foundation models, then you will need the new Siri. But with CoreAI, you don't need the new Siri essentially. And Foundation models, Apple has said they will open source it soon, but CoreAI will stay proprietary. So these are some things to note about. And that's it. I think we've come to wrap on the whole dub and how CoreAI and how Apple's take on all of this matters, and how they're positioning their various tools that they have right now to do various different things. With that out of the way, I'd like to jump into just like getting our hands a little dirty with building and authoring CoreAI compatible models with Python. So to get started, you need a neural network, and CoreAI has a great documentation on getting you started using PyTorch. If you have a PyTorch compatible, like a subclass of PyTorch neural network, then it's easy for you to export it into a CoreAI compatible model. And this is a .ai model file, which has a list of things that lets you run, that lets you inspect and run inference on your Apple platforms. And this is like I've just noted on the GitHub link, where you can check out the package that is used to do the conversions. And it has a dependency on a package called CoreAI Core, which is core to how CoreAI Torch lets you convert these models and then make it into a .ai model file. I just attached a sample code here that is shown in a WWDC session, and I've tweaked around and like gotten it to run. So what you can do is declare, like I said in the previous slide, you can have a subclass of the neural network, and you can train your networks. You can make a model. Essentially, you can make an MLP and then bring it down to CoreAI model by using the converter. So you see the CoreAI Torch being used here, and CoreAI Torch has a converter which is the 2_CoreAI method that you see here. And it's pretty easy once you get started. You can just like run this, and like your neural network object as such will become .a model file that you can later use to run inference. So the process is pretty much streamlined when you have a neural network in PyTorch. So yeah, the biggest unlock is the neural network, which was absent with Core ML, which relied on traditional machine learning frameworks. Also gives pathways for more advanced models like LLMs, which introduce a lot more nuanced concepts on top of neural networks like transformers, etc. The pipeline is this: you build any neural network, you train it, you deploy it on iOS, and it's for researchers working in this field. It's as simple as that. Yeah, versus Core ML, which lacked neural networks. So this was the whole difference that we found. So the biggest question here comes when can you take an existing model, like some open weight model, and like convert it to a model? So what Apple has is open source repository called CoreAI models, where they have recipes for these some of these models. So it features models like Quen, and it features other models, not necessarily language models. There's SAM3, etc., for segmentation. Um, you can go check it out. It's pretty rich repository that way. They also have skills for your AI agents to understand how to, author and like come up with these things. So there's no direct approach for conversion of a model. So if there's a model as such that's packaged into, like, there's an open weight model on Hugging Face maybe. There's no direct approach to take a new model and like convert it to a model. It's not like a weight based inference engine. You'll need the you'll need the modeling as well. You need to know and understand how it was made, what layers are present, in order for it to be converted into a Core compatible model. So you really need to understand how the working of a model is. This is the whole debate between open weighted models and open source models. So with open source models, which tell you how the model is built, it's much easier to uh, convert it because you understand how it works, and you just take it and you make it into a Core compatible model. There was a case study, which is something that I tinkered around with and experimented. LFM, like liquid foundation models, they launched their 2.5 230M parameter model very recently. It was released a few days ago, and it was purpose built for tool use and data extraction. And yeah, it was very like specifically built for that. And as a result, it's not meant for like your normal queries and normal reasoning. It's not meant for reasoning essentially. And not all of this model is a transformer. We'll get to that. Um, and it was extremely fast. So when it came out, I was very excited because it's an ultra small models, and we love ultra small models because of how easily you can run them right on your iPhone. So we set out and we were like, okay, let's do something. Let's take it and try to create a Core AI model out of this. And as I said before, there's no direct way to like author a Core AI model based on the weights. So you really need to understand how the model works to convert it into Core AI model. So that's what we set to do. It started off with like a base model recipe that we found, say Quen3, etc. It could be like any model. And most of LFM's model is a transformer, but they had other layers, like there were like convolution layers, and there were other layers that helped with the specific use case that LFM was targeting, which is like purpose built for like speed and tool use and data extraction. So what we had to do was like recreate this in PyTorch, recreate the modeling behind the model itself in PyTorch. And we had to bring in the whole the layers of transformers and the other hidden layers like conv as well, and implement it in PyTorch, and then run the weights through it, and then do the conversion. So that was the whole process that had to be done. And yeah, so how do you know it's correct? So you run an eval and you run inference on the .a model that was generated, and then you run it on the original LFM 2.5 as well. And you see the distribution of logics, and if you see if they match, then you know it's a success. You've successfully converted the model. So this was the success criteria, I would say. And for our conversion, the logics matched well, and we were in the correct territory. And so yeah, we were able to get this working and convert like a modern model. So LFM recipe is not something that Apple has on their Core models repo, but we were able to do this, and we were able to like bring an open weighted model, able to model it behind the scenes, and then convert it all to like a .a model file. So this was a way. And the biggest question, the overarching question is, can we templatize this? Um, and it is to a certain degree. CoreAI offers an export method, which is like a templatizable version of this, meaning you can just pass it to like a Hugging Face ID and it will like get you like an AI model. But like it's a bit more nuanced than that. You can't really create as long as the model architecture is known, you can create more of these. But if you don't know how a model was authored, then it's going to be hard for you to like kind of guess and maybe go back and forth with your agent trying to understand how a model works, and then like maybe try to figure something out. Like I said, you can have a clear win condition and then work towards the win condition, and that will help you get there in making your own .ai model file. So in a nutshell, fully automated within a family, hand authored per new architecture family. So if you have a family of models, let's say Qwen 3 is a family or LFM2 is a family, once you understand how a model is built, it's fully automated. You just have to pass the model ID and it's done. It's a done deal for you. And if not, if it's a new family, then you'll have to like hand make the model, essentially hand make the modeling of this. So yeah, that was mostly about building and authoring models using Python and converting it to Core AI. So there are some references I urge you guys to check out. It's the Core AI models itself, and there is this beautiful website wherein it's there's this person online who's released a book called The Art of Core AI, which is like an excellent read. I would urge for you guys to check it out. So these are some references in case you guys are interested. Um, yeah, thank you so much. I will pass it on to Sagar to resume with his notes.
Uh, Thank you, Sabesh. That was a really nice deep dive into Core AI. I'll just quickly share my screen. My screen is visible, right?
Yes.
Oh, hey guys. So Sabesh told us all about MLX and Core AI, how Core AI is the new thing which Apple pushes to deploy your model onto iOS devices. So here I'll take you towards like you already have the .ai model file, but now what do you do of that? How do you use it inside iOS app and stuff like that? So Core AI is a runtime. So it lets it at the end you get a folder kind of thing which has like a .ai model and could have multiple things like a tokenizer, depends on the model or what you want to do with that particular model. So Apple is just app CoreAI is just a runtime. It lets you give the AI model file that runs on your GPU, on your neural engine, on your CPU, depending on the model, the specializations, and a lot of things around that. So this handles under the hood the execution part, the specialization, and also you can, while pushing the .ai model file, you can also do ahead of time compilation, which lets you reduce the time of specialization when a user is loading the model on their devices. So these are mostly Swift APIs, and you can just use them and just get the folder.ai folder, and you can create applications on top of that. So the model artifact itself is a thing we should know nicely because it is not just a file. Like we would assume that it is just a .ai model file and you run it and it will work. No, it doesn't work like that. You get multiple things with that, which is just the whole model artifact. It contains a executable model graph, which is like the whole model converts into a graph sort of, and it has like a input token, like input and output functions, and you give it the prompt or query. If it is an image model, you probably give it an image, something like that. And it also comes with a metadata file. So that metadata file is also very important. It has stuff like how much tokens can it take, like what is the input token, context window, and like what is the size of the model and more stuff like that. The thing I was telling, the language model also need tokenizer file because a model cannot understand strings, right? We need a tokenizer which will convert string into tokens and again tokens into string. So that whole thing is the model artifact. And when we are using Core AI inside our iOS app or maybe Mac app, we don't just need the AI model file, we need the whole artifact. This is what just a demo artifact would look like. You have the model folder and you have the AI model file, then you have the JSON file, which is the whole metadata of the model. And then you would have a tokenizer in case of an LLM. And yes, we'll go ahead by what bundle gives you to the app. So it is again the deep dive into the same thing. Like tokenizer converts text into tokens and tokens into text. Also, the metadata file give you a multiple things, which is like context length defines how much context the model can handle. Model assets points to the actual .ai model file, which we load inside our app. So basically, we can just run inference. Yeah, that's mostly it. And it has like multiple functions which we can invoke as well. Uh, this is a very simple way of how to run language models. So you just import the Core AI language model function and you give it the model URL. Now this model URL uh, tells you where the whole artifact is living, and then you create a language session maybe of it, and just you actually get response. It is as simple as that session dot respond. So how Sabesh was telling that we have multiple recipes in the Core AI models repo, right? You can convert the models from there, all the LLMs, and you can as simple as use them just by giving it the model URL, creating a language model session, and just getting response from it. So the thing was that this is a very top layer of the core AI, right? When you will try to create apps, and when I was trying to create apps, what was happening was I was able to do multiple things, but when I was trying to create a vision model thing, so I wanted to create a feature that in the app what I was building, which was like you send an image and then you try to get a response from it. And the response could be ask anything to the image. Maybe it is a random image, and I ask what is happening in this image, but it was unable to do that because it was a whole different architecture. The model was also new. So the thing what I did here was there a thing called inference function. So every model or a .ai model file has multiple functions. So it takes input tensors and obviously give out some output, which are the output tensor. So I was using the inference function, and I'll go deep dive into that as well, which looks something like that. So this AI model is also from the Core AI package. And what you do is you take the AI model, give it the URL. And instead of using the direct Core AI language model, what I'm doing here is I'm loading the function of that particular AI model file. And I'm manually giving it the image input. And I'm saying the function key run and give me the output tensor itself. So the thing is key when I was trying to use Core AI, what I was facing was I was just using the upper layer of Core AI, but you have to also use the raw Core AI, which lets you do more with Core AI rather than just running LLMs. Because obviously, running LLMs is not only the use case, right? It can be many things like image, TTS, STT. Even I was implementing a thing called depth, where you could get a depth of an image. So that was also one thing. So using raw core AI is as important as using just the upper layer of the core AI. Why I went lower level was also the reason was because the thing simple session API works for basic chat, but when you come to models or use cases which are actually really different, you cannot work with that. The app we were building is called Medley, and it needed more runtime control. So the image use case was when I was trying to give the image. So I'll quickly tell like how image models work. So you give the image and the image will give you a embedding. The image, the vision model will give you a embedding, and then you have a language runtime. The embedding you will give to that model and it will tell you, okay, what was in this image. So my prompt and those embeddings go into that model. So I wanted more APIs than the simple APIs. That is why we had to go lower. We didn't have a choice and just using the core AI model thing. And yes, so in our use case, what was happening, if you ever try to use core AI, I'm guessing you'll use a single model or maybe two models. But in our use case, we are trying to use many models and trying to create a kind of gallery sort of multiple models. So we needed that streaming has to be more tighter. And to get to that, we had to use the lower APIs. That was with lower APIs. So this is what we built actually. It's an app called Medley, which lets you run on-device AI in your iPhone. This is only to iPhone, and it uses Core AI. It bundles with a lot of like capabilities where you can do AI chat, ask image, audio scribe, and also TTS and depth and multiple things I'm adding right now. So this has so many features, and yet this is just on this has no server, the inference is running on your phone, and this has nothing to do with a backend or sort of anything, which is so exciting that Core AI lets you do all of these things. You could do it with MLX as well, but Core AI gives you a little bit better performance, and I say the deployment part is a bit easy from what I've been looking at it. These were all the features which I built, which were chat, image QA, STT, TTS, and depth analysis. So this was one runtime, but many model contracts. I'll explain that briefly. Now, chat is not the running a chat model is very easy, and you can do it with simple APIs. But when you try to go in a model which is doing depth analysis, then is that then the situation gets a little bit weird where you have to use the APIs, which is like so there's a thing called engine factory. So what engine the Core AI language models under the hood uses engine factory. So I had to directly use that to get like more control over the Core AI features. This is some models run as raw graph functions. A good example would be the image model which I was using. So I was trying to load the model and then I was just calling the main function of that model because every model has some input tensors and output tensors which are invoked by via functions. So I was just calling that function directly to just use the thing. Yes, and the thing I told earlier was the when you ship a model artifact, you also ship multiple things with it. It is not just the AI model. So, which are like tokenizers or maybe ML filters. So, ML filters is something when I was trying to build STT, which was a whisper model. So, you can't shove in like MP3 audios to whisper. You have to use ML filters to make it in such a way that whisper understand it. That is how whisper architecture is made. So when I was getting the AI model file, I was also shipping the MEL filters with it. This was most of it. Like chat was language bundle plus engine.generate. Depth, whisper, vision, I had to use the inference function, which are all part of the core AI package. You can look into the package and you'll find all these multiple functions as well. TTS was more interesting where it was like multiple core AI graphs and you had to invoke two or three functions. Feature pipeline was this, where chat was just taking the prompt, tokens, and streaming the reply. Image was you take the photo, you create embeddings of that. So this is what I had to write in code, right? The core AI was doing the whole part, but the plug and play, I had to do it. So when building with core AI, language models would be easy, but other than that, maybe you'll have to do all of this, where you take the image, you create embeddings for it through the AI model file, and then you stream the reply, whatever comes out of it. In the STT, it is same as you take the log mail file, you give it to the AI model file, and then it gives you the transcript. Same with TTS and depth images as well. So where the model is a bit unique and not a normal LLM, you'll have to do some work around. So it's not just the AI model file, other than whatever the functions, tokenizer, or other things which come with it. So Core AI runs the model, but the whole pipeline behind it, we have to build that. Yeah, that was Ask Image was the most interesting feature to me because what we had to do was text decoder cannot read pixels directly. So the vision file was taking the image and writing it into image like embeddings, and that embeddings we were storing in the phone in metal buffers. And then the metal buffers, the embedding would go into the decoder, which is the language decoder, and with the prompt, it would give out some response, which we would use as like query or something. So just give the image, we turn it into embeddings, give it to the language model, and then it language decoder, and then it gives you the output as language. Most delivery is part of runtime. Yes, so models can get really huge. If like when I was shipping the iPhone app, I had like multiple models which got like really big. And the issue I was facing was if uh if you give a corrupt model folder to CoreAI, it would just break everything and even the cache of it. So the issue I was facing was I took a model, I was downloading it, and midway it stopped for some reason and would be a network issue. And what happened was when I was trying to reinstall it, again I was facing issues where CoreAI was unable to load the model, which was interesting. Like, why is this happening? Because I've downloaded it again, deleted it. But there is something called cache, the key pair compile cache. So you have to remove that first, only then re-download the model. And you should also have something like where you can pause the download part of it. So whenever you're downloading the model artifacts, what I do is I keep them in a different place, and when it is downloaded completely, only then I bring it to Core AI and try to run inference from that. Don't I don't kind of mix match both of these. Like, I'm downloading it and also trying to run Core AI on models which are not completely downloaded. It would corrupt up the cache as well, which results in specialization later. The hard part was the first load of specializing the model. So as Sabesh was explaining, specialization is nothing but the core AI, the .ai model file being like more optimized for your particular device, but that takes a little bit more than you would expect time. So a normal Quinn 2.5 2B, I guess, was taking around 1 or 2 minutes, which is a lot of time. So here you can use the ahead of time compilation, which would actually remove this time and make it like a little bit shorter. But yes, this was one of the hard things which I was facing. Why is this model taking so much time to load? And while also building this app, the thing was LLMs were easy to have as a feature, but whenever I was trying to add more features, it was like the whole life cycle has to be maintained by me myself. It is not the core AI package is doing the main part of running the model, but the whole pipeline around it, you have to build it manually yourself. And when having so many models, switching is also one thing because obviously your iPhone RAM is very limited. And if you try to load more than one model, which imagine like I tried a Gemma 4 model, which was already very big, around 4 GB sort of. And when I was trying to load another model, my phone would just shut and it would go in a panic mode because of so much RAM utilization. So whenever building a core AI feature inside your app and maybe the model is way bigger, we have to kind of figure out a way that we optimally keep the RAM clean. So it's like whenever we are loading one model, if there's already a model loaded, we just remove that and have this here. So basically the engine is safe and it has like more than just being taking the RAM consumption, it's like optimally using the models, not loading them all at once. Yeah, that were the major issues I faced when I was building this app around Core AI. This is the test flight link we have. So the app is called Medley. It is only on iOS 27 and it lets you do multiple things where you can just try like model. This is just an experimental app which we were building. This is kind of like a developer app where you can try multiple models. I'll be also try to add like more support of models and maybe newer models. Again, we are trying to build that as well. But here we are just experimenting around models so you can get a feel of running core AI models inside your iPhone. That's the major part. I guess I'll give it over to Sabesh again.
Yes, one second. I'm just trying to share the test file link on chat as well. Uh,
Uh, Actually, I can keep it for a while if you
yeah,
want.
that would be nice. One second. Yes. Awesome. I think the link has been shared on chat. Thanks, Sagar. Thank you so much for enlightening us with your sessions.
Yeah.
Yes, guys, I think we've had packed a few minutes here, and I think we have come to almost the end. The floor is open for you folks to drop questions. We'd be happy to go over and have some interesting discussions. Just harder to moderate mics, etc. So please drop a chat. Happy to go over it. So with battery performance, one thing, it's definitely better than running, the entire thing on a GPU with MLX. But it's still end of the day, you're running inference on an AI model. It's going to cost a bit of battery. Um, some evaluations are something that like these are some benchmarks that we're doing internally in house, and right now, last I checked, there were some. I ran inference on a laptop, and it was like not optimal. Like it's not optimal for you to run it on a laptop, and like when you take it, let's say you're on a flight, etc. It's probably not the best thing. We'll probably stick to having it on device on like a Mac Studio or something on Mac Mini. Um, but yeah, for trying to see and optimize how like the previous example I was talking about was sustained load. So like when you want to run like a full agent on something, that's the type of performance I was talking about, not like smaller use cases. So we're still trying to figure out how to optimize battery and like efficiency on smaller devices like iOS. I think we'll make some findings soon and like maybe publish benchmarks on this. That'll be cool. Use cases that seem obvious for local models on the iPhone. Mm, if
I
you,
can think of
yeah,
some
go.
use cases actually. Uh, so while I was building this, and there are many character application which like tries to give you multiple characters sort of. You can use multiple models around that as well. And there's a thing called dynamic profiles in Apple Foundation framework right now. And what you can do is like have multiple dynamic profiles and a nice model which is smart enough to act as that. Because I think the AFM model wouldn't do that. So if you can have like a Quinn model or something inside the app and have like multiple profiles so people can chat with that. That would be an interesting use case because this has been on the web. This is a thing, but I don't think there are many local iOS apps around this. That would be cool actually.
Um,
Yes.
Sweet spot of quantization. I think for let's say, um, okay, so for the heating question and tokens per second, I urge you folks to take a look at a research paper that we published, which talks about AI on the edge. I think Kotok or someone can drop a link here, wherein we published benchmarks on what happened when we ran MLX workloads on iPhone, along with a bunch of other devices, and how thermal throttling happened, and how we can handle it or navigate this. TLDR, it was not looking good, especially for sustained loads. It's not something that is something that we have under our control, because when you keep pushing the system to run more inference, then it's going to be a big deal for it to come up with. Yeah, I think research paper has been shared by multiple people. So have a look at this. We've published like very elaborate benchmarks there. Um, for quantization, I would say 4-bit quantized has meaningful quality for smaller sizes. And if you ask me or anyone like Sagar, etc., we really are very optimistic about extremely small models that run on your phone. So we want to get there, and we want to do whatever is in our power to get there. So I think it's not a question about quantity. It's not like as general as, oh, do I prefer 4-bit or 8-bit? It's more about, hey, can I get meaningful quality in the smallest size I can find? So that's the question that we're trying to ask ourselves like every day almost, and like trying to find a balance. And when you push your model size smaller, by theory, you should be getting like speed up. So that's also a benefit, obviously. Like when you must have seen how 4-bit models are faster than 8-bits, but I think we look at it from not a speed perspective. We look at it from a, oh, can it do the job that it's supposed to do in lesser footprint perspective? So when you are able to achieve that, then you can package like these army of smaller models into consumer devices that can be run on millions and millions of iPhones. And I think that the prospect of that is cool. Okay. So is there a separate framework for agentic AI on Apple? Uh, there is. So with Core AI, so there's been a bunch of you know um, changes in the landscape about agent orchestration in Swift and Apple platforms. With foundation models, I think this is exactly what they're trying to achieve, wherein they have brought in dynamic profiles. They brought in a bunch of features this year with Apple, and that lets you build agentic interfaces yourself, wherein you can program these with now the options are limitless. You can bring in Apple's own model, you can bring in Apple's own private cloud compute model, you can bring in your own model, you can bring in your own inference engine. So I think the opportunities are limitless to build your own agentic AI pipeline right now. And I think you might be it might be best for you to look into the foundation model framework for you to understand how it works. And I think that's a great way to get started with agentic AI. With creating .ai models without proper modeling. So yes, it's a mixture of both. For LFM, there are some documentations that talk about these layers. I think I can't find it right now. I have to go through search and find the links for these things. But it was some research I did, some lot of back and forth with a lot of agents, and just trying to figure out those extra layers, or those basically the structure of how the model came into existence. So once you crack that, it's pretty good. For open source models, wherein the process of building the model is open, it's going to be like much easier, because you just read how it's built and you can implement it, or rather the code for that is open source as well. Python or PyTorch code is open source, and I think that's like much better way. So you can just like understand and then compile it, like you can convert it into a .ai model. For other models that are like maybe open weighted, but you don't know how they are implemented, it's going to be a little tricky in understanding how to build it, because all you have are numbers and you need to understand the layers. It could be just like so a good way like I was going through was like see how it gets inferenced, so which inference engine uses it, and then like work maybe backwards and see what sort of neural network I can put, what sort of layers it might have, etc. And then like you know do a back and forth with some agents and like figure it out and then like build it. So that was my whole process in this thing. And for one or two models that we've been working with, it's worked out pretty well. And there's one or two specific people that are doing this thing like very aggressively. You can see it on the internet. The book I shared, The Art of CoreAI, that guy, insane guy. He was doing a lot of model conversion. He has this model zoo thing in GitHub, wherein he's been converting a bunch of models and putting them out in CoreAI format. So that's pretty cool. Yeah.
Hey, Sabesh, I would like to add one more point. There's a very nice YouTube video which I am sharing, and in this, basically what you can do is there's a thing called CoreAI debugger, where you can go and see the model graph actually, and you can figure out like what's wrong in the architecture, or like maybe some function is performing wrong, and you can also correct that. So that also adds to, so when you're building a new Core AI like model file, it gets like really hard, and I tried it and it was like really hard. You have to like know what the model architecture is, and also if you face any issues, you should just go to the debugger and try to solve that if you have the knowledge around the model architecture and the functions it has.
I think we brushed past the whole debugger thing. This year the evals and debugging framework was also like pretty emphasized. So good
Yes.
stuff. Awesome. Yeah, I think please, folks who are remaining, drop if you have anything, please drop it here. If not, let's call it a wrap. Yes, I'll wait for a minute. Oh, I see. I see a couple of things. Um, yeah. So I mean, Core AI is basically like the proprietary thing that these guys have come up with, Apple. So it's going to be always best for you to, if you want to adhere to, App Store and um, ship to get reach to more users. I think it's always better to use Core AI over any other framework, I would say. MLX is a good second part. But yeah, like it's come to, like I emphasized on my first session, it's come to like kind of take over the whole inference engine platform on Apple platforms. So yeah. Yeah, I'm checking out this question as well. Um, no, you can't expose your AI model as a service to random apps. You can only do it to apps that your app groups are part of. Like, as in, you can add your apps to an app group and then you can host it. Like, you can download let's say, the user downloads a model and then they can use it on the other app. You can't expose it to a random app because that's a violation of, like, that doesn't, your apps are sandboxed and you can't do that by design.
Mhm.
Which is why it's also like very private to use apps on iOS. In general, you can't like Swiggy can't access Uber's data, etc. Sagar, you had something?
On maybe Mac you can do it, but on the iOS it's not possible. On the Mac you can like Mac you can open a MCP server or maybe a server which could just use the model. But on the iPhone, I don't think it's possible.
iOS, it's not possible. Yeah. In such fallback cases, I think best would be to leverage the foundation model. Um,
Hmm.
I mean, if you're not for some reason happy with its performance or efficiency, that's not something we can help. But foundation model is available with the system, so it's accessible in every app. So that is something we can do. Okay, I think we've reached the end here. Thank you so much, guys. Thank you so much for attending and sticking around on a nice Saturday evening when you could have been doing a bunch of other things. But thank you so much for being here, Sagar.
Yeah, thank you for joining, guys, and it was great to have you all here. Nice questions.
Yeah, I think we had great discussions today.